Find the slope of the line that goes through the ordered pairs 7, comma, -1 and -3, comma, -1. Let me just do a quick graph of these just so we can visualize what they look like. So let me draw a quick graph over here. So our first point is 7, comma, -1. So 1, 2, 3, 4, 5, 6, 7. This is the x-axis. 7, comma, -1. So 7, comma, -1 is right over there. 7, -1. This, of course, is the y-axis. And then the next point is -3, comma, -1. So we go back 3 in the horizontal direction, -3, but the y-coordinate is still -1. It's still -1. So the line that connects these 2 points will look like this. It will look like that. Now, they're asking us to find the slope of the line that goes through the ordered pairs. Find the slope of this line. And just to give a little bit of intuition here, slope is a measure of a line's inclination. And the way that it's defined, slope is defined as rise over run, or change in y over change in x, or sometimes you'll see it defined as the variable m, and then they'll define change in y as just being the second y coordinate minus the first y coordinate, and then the change in x as the second x coordinate minus the first x coordinate. These are all different variations in slope, but hopefully you appreciate that these are measuring inclination. If I rise a ton when I run a little bit, if I move a little bit in the x direction and I rise a bunch, then I have a very steep line. I have a very steep upward sloping line. If I don't change at all when I run a bit, then I have a very low slope, and that's actually what's happening here. I'm going from, you could either view this as the starting point or view this as the starting point, but let's view this as the starting point. So this -3, comma, 1. If I go from -3, comma, -1 to 7, comma, -1, I'm running a good bit. I'm going from -3, my x value is -3 here, and it goes all the way to 7. So my change in x here is 10. To go from -3 to 7, I changed my x value by 10. But what's my change in y? Well, my y value here is -1, and my y value over here is still -1. So my change in y is 0. My change in y is going to be 0. My y value does not change no matter how much I change my x value. So the slope here is going to be, when we run 10, what was our rise? How much did we change in y? Well, we didn't rise at all. We didn't go up or down. So the slope here is 0. Or another way to think about it is this line has no inclination. It's a completely flat, it's a completely horizontal line. So this should make sense. This is a 0. The slope here is 0. And just to make sure that this gels with all of these other formulas that you might know, but I want to make it very clear, these are all just telling you rise over run, or change in y over change in x, a way to measure inclination. But let's just apply them, just so hopefully it all makes sense to you. So we could also say slope is change in y over change in x. If we take this to be our start, and if we take this to be our endpoint, then we would call this over here x1, and then this is over here, this is y1, and then we would call this x2, and we would call this y2, if this is our start point and that is our end point. And so the slope here, the change in y2 minus y1, so it's -1 minus -1, all of that over x2, -3 minus x1, -7. So the numerator, -1 minus -1, that's the same thing as -1 plus 1. And our denominator is -3 minus 7, which is -10. So once again, -1 plus 1 is 0 over -10. And this is still going to be 0. And the only reason why we got a -10 here and a +10 there is because we swapped the starting and the ending points. In this example right over here, we took this as the start point and made this coordinate over here as the end point. Over here, we swapped them around. 7, -1 was our start point, and -3, -1 is our end point. So if we start over here, our change in x is going to be -10. but our change in y is still going to be 0. So regardless of how you do it, the slope of this line is 0. It's a horizontal line.